So let's take a look at this following linear line that I've got here graphed. And specifically, let's have a look at how we might find the equation of this linear line generally in what we call gradient point form. So to do this, let's just consider a point along this graph. Let's say I've got this point right here. And generally speaking, rather than not describing that point as a specific point in the graph, let's call that point A, so the x-coordinate, with the y-coordinate B. We're going to do this because I want to see if there's a shortcut way that we can very quickly find the equation of this line using our gradient point sort of format. Now at the moment we don't have any information on this graph at all. We know it's going to have a point AB somewhere, and its slope could be anything. I could redraw this line any way that I want. But what we do know is if we consider another point along this line, let's just say this point over here with the coordinate x and y, we can find the gradient of this line. So we can find the gradient of this line by finding the rise divided by the run, or the difference of our y divided by the difference of our x. So to do the difference here, what we would do is we would do this y here, take the y coordinate here, so it'll be y subtract our b value, and then all that will be divided by the run, so our x subtract the a. But of course, we've been referring to the gradient with the letter m up until this point, so we can say this gradient is equal to m. Just generally speaking. Now, what we've actually got here is an equation already that describes this linear line that I've got here, generally speaking. And if I do actually know the values of this coordinate and the slope, I can find the equation of that linear line really quickly. But I can rearrange this, and I can rearrange it in one of two ways. I could start by just multiplying both sides here by a minus b. On the left-hand side, I'll cancel it out and just leave this y subtract the b value. And when I multiply it over here, it will equal my m value multiplied by this x minus b, minus a, sorry. And what I've actually just done here is found, just generally speaking, a shortcut rule to be able to find or describe this linear line, whatever type of linear line that I've got, in gradient point form. This is gradient point form. You can take it one step further and rearrange this to make y the subject of the equation by just saying y equals, you're going to add b on the other side, so it'll be m x minus my a, and then add my b value. So it can look in this format here, but both of them are using that method of gradient point form to be able to quickly find the equation. So similar to in other methods I've shown previously, you do still need two pieces of information to describe the equation and of this specific line. You'll need a point and you'll need the slope. So let's say you've got an equation where we know that our slope is 3, so our m is equal to 3, and we know that we've got the point, say let's passes through to 5. So passes through to 5. What we can do with this is we can describe this equation of the linear line by just substitution. So we know that this value here is my a, this value here is my b, and my m is equal to 3. So if I now substitute it into this format just here, I can say that the equation is y equals my m of 3, x minus a, so x minus 2, and then add my b, so add my 5. And what I can do from here is I can expand this out and simplify it. So this will be y equals 3x. 3 times negative 2 will be negative 6. Negative 6 plus 5 is negative 1. So my equation in simplest form of that particular line can be represented by y equals 3x minus 1. Now, both of these formats have their uses. They are the exact same equation, it's just been rearranged. But when we use this format to very quickly find the equation of the linear line, we call this process finding the equation via gradient point form.